Hey there everyone, all the techies and data enthusiasts there. Welcome back to my YouTube channel. So guys, this is video 6 of our generative AI using Django series, and in this particular video we are going to discuss about generative models. So what are generative models? The models of transformers, you can say, which has the generative capabilities. In essence, you know that in transformer we have encoder and decoder. What encoder does, it analyzes the input and it creates its own encoding, then sends to the decoder, and decoder generates based on it. Okay, so here the same way we will be discussing about some of the generative models. In essence, that is nothing but decoder based models, decoder architecture based models, which are nothing but you get GANs, VAE, which is nothing but ventilation autoencoders, and generative pre-trained transformers, which is nothing but GPTs, and many more decoder based models. So we will be discussing about them in detail in this particular video. So guys, make sure to subscribe the channel, on the bell notification, and if you like this particular video, do share this video with your friends and even post on LinkedIn. Tag me, I'll definitely respond to your posts. So guys, now let's get started. So guys, in today's video we will generally see what are generative models and different types of generative models, that is nothing but decoder based models, and we will go with the practical implementation as well. So there is a simple practical implementation, I'll show you all that as well. Afterwards, this is just to show how it works, and it's not mostly related to Django in this particular video what implementation I do. That is just for your understanding. Afterwards, going forward, we will be doing the end-to-end projects, then we will be using Django there. Okay, so introduction to generative models. Generative models are a fascinating area of artificial intelligence that focus on creating new data samples from learned patterns in existing data. This means that these particular models are decoder based transformer models, or you know that transformer architecture, right? In that it's a decoder based model which has generation capabilities. So how do they generate data? They generate data, or they generate output based on the patterns it has learned. So previously whatever data we have given to the model and we have trained it, based on that the model will be able to generate the output, whether it can be generating realistic images, text or audio and more. Among them, the most notable generative models are nothing but GANs, which is nothing but generative adversarial neural network or networks, ventilation autoencoders VAE, and generative pre-trained transformers, which is one of the important concept among this all, which is nothing but GPT. So GANs and ventilation autoencoders, these are mainly used for computer vision related tasks, and when we are working with image related data, then we use it. But normally GPTs are used for text generation as well. So GPT model was first developed by OpenAI only, based on transformers architecture that are specifically designed for natural language processing tasks. They utilize an auto-regressive approach to generate text one word at a time, conditioning each word of the previously generated word. Meaning, so how does GPTs normally work? Whatever data it is going to generate, it understands the question mainly, and one word at a time. Whatever output is generated, it's one word at a time. Also, it remembers the previous word. It's not like some RNN or LSTM that it has a forgetting problem. It will definitely remember, and based on previous word, it will predict the next word. How do they work? Transformers architecture use attention mechanism to decode the importance of different words in context. Pre-training and fine-tuning. Initially trained on vast amount of data, then we got the option to fine-tune and pre-train. Means like before fine-tuning process and pre-training process, how the models used to be, like if you are going to train a particular model, then you have to provide a vast amount of data, millions and millions of data, and you create a model over. So if there is any error in the model, again start from first completely training, which was a kind of what you say, like more energy is required and more resources required, and time used to take more, lots of time. To overcome this, what researchers have done, they started to figure out how to create a pre-trained model. which is nothing but a simple already available trained model. If the model is perfect, we store it, we save the model, later we fine tune the model, or we just use transfer learning and tune the model. This is how it normally works. So based because of this pre-training or fine-tuning, because of this fine-tuning and transfer learning methods, so lots and lots of resource usage has been saved actually. Now today in this video also we will see how to actually fine-tune a GPT model or generate answers from it. Applications: text generation. GPTs can be used for writing articles, essays and poets based on prompts. Okay, so now also if you go to ChatGPT and provide it, it will be done. Chatbot, used in customer service application to simulate human-like conversation. So these can be used as a chatbots as well. Mostly the ChatGPTs which are doing, but specifically if you want it for custom task, like specifically for customer service, now you have Alexa, and each company has their own customer service bots actually. HDFC has its own bots, and even Kotak, all the banks have their own custom bots, Zepto, Zomato, and yeah, Amazon. I remember Amazon's bot, which is Rufus, which was recently launched. So if you search any product in Amazon using Rufus, you will immediately get details about it. You can go and give a try on it. All these are GPT based only. Code generation. Assistants develop developers by generating code snippets based on description. Obviously, this is being done right now by ChatGPTs and GitHub Copilot. You have Microsoft Copilot. So this Copilot, which you already always have it available here. So even they generate the codes for you. But the problem is, whatever code you are writing, everything is being memorized or everything is being fine-tuned, used for model training again. So whatever unique logics you are going to write, always you have to remember that those code logics and those code structures are not being completely given to model for privacy issues. Okay, for your company's privacy issues. Examples: OpenAI GPT-3 has been used to create conversational agents that can engage users in meaningful dialogues and assistance with writing tasks. GANs, Generative Adversarial Neural Networks, introduced by Lan Goodfellow on his colleagues in 2014. So GANs mainly consists of two neural networks. One is generator and the discriminator. Generator creates synthetic data from random noise, while the discriminator evaluates whether the data is real or generated. This setup creates a competitive environment where both networks improve over time. So what generator, why we have generator and discriminator? So in generator, you give it a, for suppose you give it an input, based on that and the data, it creates a sample data. Okay, synthetic data has been generated. Then discriminator evaluates whether it's real data or generated data. Okay, here you have an image of it. You can see here, based on discriminators feedback only, this generator again continues to generate. Over time of this continuous loop process, the model learns itself how to generate perfect data which could be real, and reducing more fake data and reducing the noise over data as well. Applications: image generation, art creation, so it can be used in generating high quality images. These GANs are only used in your Stable Diffuser, which is your open source model, and in OpenAI's you have DALL-E 3 and Google's Image Gen 3 and deep fakes to create a realistic videos that could actually never been said or never been created. Those kind of videos also can be created using this particular discriminators and generators. So generating photorealistic human face and everything. However, if you guys remember, when DALL-E was first released, not only DALL-E, the image generation models was first released. That time, how the models used to generate the images, like literally, it used to generate human hands with 6 fingers, 7 fingers, and face used to not at all look that clear. So some kind of like nose used to look somewhat big, broad. So that time those particular images were not that clear actually. Over time the model has learned how to create a perfect images, and now whatever the model generates the realistic image, it's very difficult to find out whether it's a real human or an AI generated human. So that extent the model has grown, how based on providing the real data, continuous usage of the data and what you are doing, so that data is being fed to the model. Over time the image generation process was improved. Now also if you use ideogram, you will generate a very realistic image, which is very difficult to figure out if it was a real human or a AI generated. Ventilation autoencoders VAEs was developed by the same time or developed on the same time as GANs. They consist of two components, which is encoder, decoder. They learn to encode input data from a compressed representation, which is nothing but latent space, and then decode it back to reconstruct the original data. How do they work? Encoder compress input into a low dimensional latent space. Then latent space represents the essential feature of the input data probabilistically. Decoder reconstruct the data from the latent space. So this is how it happens normally. So I'm not going to explain them very detailed because our concept is to mainly learn generative AI. These all models you can learn separately as well. So I'm just giving them an overview while we are working on project. You don't get any issues. Application of VAE image generation. It can be used for anomaly detection to detect the anomaly patterns, data imputation, filtering the missing values in data, and even it can generate the synthetic images as well, which can be used for retraining. So after all this, then the birthplace of transformers and AI era, new era. So what is transformers? To understand LLMs, you must first travel back to 2017 when researchers of Google unveiled a groundbreaking architecture called transformers. So before transformers and after transformers, now the situation is like that only, guys. Before transformers, the models or this actually these AI models used to struggle a lot. RNNs, LSTMs, GRU, there was a forgetting issue. Model doesn't remember properly, and when it goes to the generation, computational time taking computation is used to be very more, and chatbots also were mostly rule based engines. But now, after 2017, when the Transformers was first released by Google, you can see the great changes right now. You have automatic conversation bots, self retrieve, self rag, you have self correct your rag or adapt your rag, all these kind of different rag techniques as well, where the model can itself learn and itself also it can correct. So, this is the great updates right now. What is a transformer model? A transformer is a type of deep learning model designed to handle sequential data like text without relying on traditional recurrent architectures. It uses a mechanism called self-attention to understand the relationship between words in a sequence, allowing it to capture long range dependencies more effectively. So transformers, though I'm not going to go in very detail, guys. Transformers are a type of neural network model or an architecture of a model which was released on 2017 by Google in the paper called Attention is All You Need, where when you give an input, the model has the capability to do parallel processing, and also it can tag the positions and generate answers comparatively faster compared to RNNs and GRU. Only this I can tell you for now, and more than this you don't need anything as well. So if you want to learn in detail about transformers, I already have created a complete transformers playlist, so you can check out that. I'll provide the video link or playlist link in this video description. Okay, so let's move forward. Transformers in generative AI for text generation. So the advanced deep neural network model. So as I already told you, now these particular models, whichever are built like GPTs or GANs, they have generative capabilities. So now your chat GPT, how it is able to generate the answer based on your input question, that is based on the transformers architecture and specifically the decoder architecture and its generative capabilities. The advantages of transformer model includes the scalability, efficiency in training, and ability to handle large input sequences without losing contextual information. They have become the backbone of many state-of-the-art models such as GPT, Llama, and BERT during significant improvements in various NLP applications. For more details, so please check out the Transformers playlist to learn completely about Transformers. Each and every uh, component of Transformer, you can say, in architecture, I have clearly decoded and created a separate video on it, whether it can be positional encoding, what is encoder decoder, what is attention mechanism, masked multi-head attention, self attention. So all these topics whatever are there in transformers architecture, each and everything is clearly explained. How transformers generate the text? So simple, when you give an input text, so it is tokenized and the embeddings are created, then position encoding is done, and then self attention mechanism comes into picture, then decoder process starts. So based on the self attention mechanism output we get, so that particular and normalized output using softmax, again we normalize it with that output we get, we then send it to decoder, and decoder based on the encoder's final output which we got, it generates an output and the output generation is done. So popular models of text generation is GPT-T5, which is nothing but text to text. This is a encoder decoder combination model. So and BART and XLNet. So how this generative models work in text generation, so that we will practically see here. Let me connect my notebook here. So we will be using transformers library directly and torch, PyTorch. So it's taking time to connect now. Okay, so let's start to install. First let us install transformers and torch. Okay. So this will take some time actually to install, and I recommend you to use Google Colab only, because if you try to use Jupyter Notebook or anything, you have to install all these configurations, install all these models locally, and those setup errors, it will take more time. Google Colab has everything inbuilt functionalities set up ready, so you can use this instead of that. Now let us see how this works going forward. So this installation is taking more time. We will be using GPT-2 for this particular example which I am showing you all. You can also use GPT-2 medium, large, or GPT-2 XL. So you have these many models, you can use any of them according to your requirements. But for me right now, normal GPT-2 is enough. Okay, so this installation is actually taking some time. Let's wait for it to complete. Yeah, it's done. So it approximately took 1 minute. In your laptop it may take 4 or 5 minutes also if your laptop is not having any GPU. So I'm telling you to use Google Colab. You can see here now we are loading the GPT-2 model, and it's loading right now. When it's getting downloaded, Okay, so it has started to download. You can see here all the models, safe tensors. Actually, this particular GPT-2 model, right, we are downloading it from Hugging Face. You can see here Hugging Face Hub. So what is Hugging Face? Those who all don't know what is Hugging Face, if you go to Hugging Face, one second. Yeah. So this is your Hugging Face actually. Here in Spaces you can test the models, but now what we will do, I'll directly show you the models which are available which you can use. Here if I go and search for GPT-2, that's enough. See, OpenAI community GPT-2. This is the model which you can later use it. So here you have the model trained and you have their files and versions and their safe tensors, everything here available. So actually this is what has been used there internally. We have downloaded this particular model only. It's 1 year was the last commit done. You can see here this particular model is still under continuous updates. It's an open source model, so open source community people will also be contributing. Even you can give a try on it. You can use either transformers or VLLM. So we will go with transformers. For that you have to copy this particular code and run there. So I have already written this, so I don't need to specifically do it. Now see here, set the model to evaluate mode. Okay, model.evaluate prompt is equals to once upon a time in a small village. So we gave a prompt till there, then encode the input prompt and we are running it. We are telling it to generate the output. You can see our max length is 100, generated text is 100, number of written sequence 1, no repeated n-gram size, that is equals to 2, earliest dropping is equals to true, and temperature is 07. We are telling the model to be more creative. However, we are just testing, so it's not a problem. We are telling the model to be more creative and it has created the encoder output here. Now decoder's output to generate the output. You can see here. Once upon a time in a small village, a young girl named Nana was kidnapped by a group of bandits. She was taken to a village where she was forced to work, and the bandits took her to the village of Keen, where they took Nana on her family. So here Nana's story is told in the book, the story of Nanya. Nanya is the character in the Tale of Two Cities. She is daughter of. So still here we have given only 100, right? So once the 100 text size has reached, so it has auto stopped here. You can see here it has randomly generated the output. So let us run this again. There was a small village, right? So let us change this to small city. So let us rerun this. And let us run this. You can see here, once upon a time in a small city, a man named The Man was a young man who had been living in the city for few years. He was an old man and he was very good at his job. The man was the man he had always wanted to be. This model is not perfect, but you can see her name is also The Man. So it is actually trying to hallucinate, or it is not providing a proper answer, but it has tried its great extent to create something meaningful output here. The man had a very strong sense of humor. His sense was that he could be a good man and he would be, but he didn't know how to do so. So he then, till here you can see here, then the model stopped. Max length has been reached, so the model stopped here. This is how a normal GPT-2 works. So practical implementation is also shown here, how it generates a text, open source model. and a basic explanation is done. I hope you all felt this video interesting. So guys, if you like this video, do like, share and subscribe the channel. Make sure to copy this video link and definitely post it on LinkedIn. Tag me, I'll support you all. Even I'll also react to your particular posts. Let us all work together. In a sense, let us build an open source community here. Okay guys, so that's all for today's video. Bye bye. Meet you all in next video. Bye.